Okay, this is chapter 3 and 4 review for the semester exam. If you didn't already watch the chapter 1 and 2, that was in a separate video. Also, chapter 5 and 6 are in a separate video. Not that you have to watch them, but just make sure you know they exist. Okay, number 27. The graph to the right is a transformation of the parent function, y is equal to x to the third. That's a, yeah, I mean, it says it. That's a parent function. Describe the transformation. So you don't have to write the equation, you just have to say the transformation, which means I went to the left, and then I went down. So I went 1, 2, 3 to the left, so left 3, and I went down 2, so that's all I need for that one. Left 3, down 2. 28, the graphs below form different parent, the graphs below are from different parent functions. Which parent functions are they from? What's the name in the equation? So just to get you some, this is a square root, is the name, and the equation is equal to the square root of x. This is an absolute value. Now, again, keep in mind, these aren't the parent functions. I'm just trying to get you to see what the parent function, or where it started, what the parent function would be. And essentially, you're just looking at the shape of the graph. So absolute value, and that's y is equal to the absolute value of x. This little squiggle is a cubic, which is y is equal to x to the third, or x cubed, if that's what we want to call it. And this one is a quadratic. Don't put parabola for this one. A couple people have done that. Quadratic, and it's y is equal to x squared. Draw a quick sketch of each type of graph. So this one, it's not saying draw a quick sketch of the parent function. Want to draw the parent function for this? I'm just checking the shape for this. Quadratic with some. I was aiming for the parent function, but I missed, but that's okay. A square root looks something like this. Cubic comes up and is a little squiggle. And absolute value is a V shape. It's not a good shape. I hesitated. Vertex and axis of symmetry. I give you a picture, so your axis of symmetry, axis of symmetry, remember, it's the one that goes right through the vertex. It's the one where everything is reflected across. It's the axis of symmetry, it's the line that makes it symmetrical. So the axis of symmetry right there is x is equal to 1. If you just put 1, it's not a huge deal. And remember, on the final exam, it's multiple choice, so it's probably, I'm not going to make it where A is and B is x is equal to 1. So I'm not going to try to trick you with that. So again, not a huge, technically, because it's a vertical line, but again, I'm not that finicky about that. Your vertex is an ordered pair. You go over 1, up 2. That one is an ordered pair, so make sure you're putting that ordered pair in there. For each below, list the transformation from the parent function. So list the transformation from the parent function. Formula sheet for this. So you have this formula sheet is the one you'll be able to use on the final exam. So it's got the formula, slope-intercept form, point slope form, standard form, quadratic formula, discriminant, all that stuff is on there. But I also included this one, left, right, up, down. And we have the H, K, and C, and then it kind of tells you what each of those things are. After that, I kind of gave you this little bit of a shortcut that I think helps some of you. So if it's inside here, it is left and right. Plus is left, plus is left, minus is right. Outside is up and down. Plus is up, minus is down. Here, negative is x. This is technically nothing you have to do on the final exam, but this is what you do first, and the last one you do is up and down. On the final exam, it's plus 3 minus 2, plus 3 in here, minus 2 in back. You can also look up here, plus minus 2. That means we 3 down 2. If that number is smaller than so compression by factor technically you should say it's a vertical compression by a factor of 1/2, but that's pretty long. So for our purpose, just say compression by 1/2, and then up. Whoops, that was good. Up 3, 1, and then a vertical stretch by 3, since that number is bigger than 1, and last across x-axis. The system by graphing is this one. Over 3, and again, I do this. Oh, that's wrong. Up 1 over 3, and then remember, if I go up and to the left over 3, like I said, just to make sure everything. When you subtract x, the negative 3x minus 6 1 is equal to positive 3x minus 6, so negative 6. So negative 6 knew that I assumed that I went back to check is this one would give me a weird decimal. Where do they intersect? Well, this one would intersect like right here. So again, but kind of thing. Y-intercept is positive. Up 3 graph, 3 to the left 1. Again, until I hit my other graph. And now you know exactly where that point is. You go to the left 3 and down 3. Make which order that goes, because those are the same number on the test. It might not be like that. So it's a sketch graph that has no solution parallel, which means they have to have the same slope. So if you just do this, that's not good enough. I need to see that they have the same slope. We're going, but again, I need to stick with that. So it doesn't matter where you put these. I'm going to start here, and let's do up 1 over 2. Up 1 over 2. Then I'll do down here, up 1 over 2. Up 1 over 2. Doesn't make any difference. This one I kind of missed. But I need to see your slopes for that. For this one, I need substitutions. Substitute equal to this. X minus 2. Y, I take it out, I plug in the 3x plus 2 is equal to negative 4. So just that negative 2. X minus negative 4. 6x minus 6x cancel. So that's just 0. So already when your variables cancel, something's a little interesting or something's a little fishy, that's when you have to double check if it's true or false. Since this is true, it's real numbers. It was, oh, actually, it's multiple, but since this stuff, it's not real numbers, it's infinitely. Go into the difference between that because I don't want to confuse you guys. Again, would use equation by -2. So I have -2x plus y is equal to -2. My second equation. Anything else with it? So those cancel. 8 minus 3 is 5. -2 minus 8 is -10. So you divide both sides by 5. Y is equal to -2. Once you have your y is equal to -2, remember you have to plug that back into x. I would plug it into this equation. X minus 4 times -2 is equal to 1. That's x plus 8, -4 times -2, if you want to look at it that way, which I think is the easiest way to look at it. Subtract 8, I get x is equal to -7. So you get -7, -2. Now during class, I told you I don't care if you put it as an ordered pair, as long as you label. Just keep in mind that this is multiple choice, so the answers will be in ordered pairs. So if you don't usually put your answers in ordered pairs, but you understand how to get it there, that's fine, that's good enough. But if you don't do ordered pairs because you're not sure which one is which, then definitely make sure you study up on that. '36, same thing. I would do. So for equation, cancel y's, it doesn't make any difference. 12x minus 15y equal to -15. Multiply by +5, 35y plus 15, sorry, 35x plus equal to times 5 is 3. Negative 15. If you divide both sides by 23, you get x is equal to, once you have x is equal to that in this equation, I think that's probably the easiest. Use any of them. 4 times x equal to 5. 5y is equal to, divide both sides by 5. Y is equal to -3. So this one should be 5, -3 is your answer for that. Graph the system inequalities. Both of these will start by, actually, I'm going to solve this second one first. Not necessarily. So subtract x. I get y is less than or equal to 1/2 x plus 3. My y-intercept is +3. My slope is down 1/2. 1/2. Space for this. Y is less than 5. Subtract your 2x. -5y is less than -2x plus 5. Then divide everything. When you divide by -5, you have to flip that sign. So y is greater than 2/5x minus 1. So -1 is right here. I go up 2/1, 2, 3, 4, 5. It is a dotted line. But we do have to shade. So I go back, actually, a little lighter. So if you look at this one, and so we shade under. So under the blue, above the red. So where's that overlap? Below the blue, above the red. That's everything over here in this section. All right, the last one for this, or for this. Not the last one, for a couple. Okay. Has 10-pound weights and 25-pound weights. He has 11 weights altogether that total 185 pounds. How many of each size does he have? So a good way to label these on X is 10-pound weights. Y is my 25. The equation, he has 11 weights altogether, so that means if you take his 10-pound weights and add those to how many? They also total 180 pounds, so it'll be 10 pounds, however many weights there are. That equals 185 pounds. It's also set up pretty nicely for elimination, so I'm going to multiply the equation by -10. Maybe just set it up, and so that. But this one doesn't say that, so let's go ahead and solve just. So you get -10x, 10y is equal to -110. Equation doesn't change. 10x plus 25y is equal to 185. Cancel. -10 plus 25. -110 plus 185 is 75. If I divide both by 15, I get y is equal to 5. So that's really helpful. Again, on weights, he has 25-pound weights. So how many 10-pound weights does he have? We'll go back. He has 11 weights altogether. 5 of them are 20. Be 10-pound weights. So again, this is going to be the answer, what it's going to ask for, if it's just the formula or it's the answers. But just to make sure you remember, that means there are 10 weights and 5 weights. You don't have to, I just think it's a little less confusing to have two numbers like that to spell one of them out. Number 39. This is the bag. If you are interested, you can look up, well, if you have it, I don't know if the other, if you're interested, three system with a matrix. If you have a graphing calculator, you certainly can. But also, I will say, this is multiple choice. So if you have is 3, -2, and 0, 1, 2, and C is whatever. You could, this one might be easier. Put those in for each one of these, and yours has to make all of them true. Whichever one makes the first equation 6, the second equation 7, and the third equation work for all three of those. So that might not be a bad idea, especially because I'm going to bet a lot of them work with the, don't even work with the first one. So it's not even like you have to plug in all three. I bet a lot of the answers, you plug in the first one, they won't be 6, and so that's already not the answer. So that's what I would encourage you to do on the final exam, especially when you get to people are like nervous about it. I do this just because during the class, label them as well. And then you could cancel out Z first. You could cancel out Y, but it would not be ideal. It worked really well for A and B. You could cancel, but then to cancel C, you have to do a little bit more work, but it's possible. I'm going to cancel my X's. I think that's going to be the easiest. I'm going to take my equation B. It's -1 times B. X 2y. And that with my equation C, positive x minus 3y minus 2 gives you negative y minus 3z is equal to negative 2. I call that equation D. Then my second step, so we can put it in. Remember, the biggest thing with your second step is if you cancel the x's in your first step, you have to cancel the same variable in your second step. You have to. If you don't, you're going to get some things. I'm going to take my equation A is 2x plus 4y plus 3z is equal to 6. And that 2, doesn't matter which one you pick, I'm going to do, but I have to multiply b by negative 2. So that's negative 2x plus 4y minus 2z is equal to positive 10. So those cancel. We get 8y plus z is equal to 16, and I call that my equation E. And that is a y, is more specific. Again, the reason you had to cancel the same variables in step 1 and step 2 is because now we have the x's gone, but both the equations we have left have a y and a z. So we're getting a little bit closer now. D and E, and we put those together to cancel something. So what I will probably do is I will so D is E, I'm going to multiply 3. Is equal to 48. Is equal to plus 48 is 46. We get y is equal to 2. So once we get y is equal to quicker, because now we're just plugging things in and finding our answers. So I'm going to plug it into equation D now. Remember, now to find out your other variables, you first start with either D or E to find your Z, because we're ahead of our Y. I'm going to do equation D for that one. So it's going to be 2, because you plug in your Y, minus 3Z is equal to negative 2. So negative minus 3Z is equal to negative 2. When you add 2, you get 0, which is kind of strange, but that is okay. By both sides by negative 3, you get Z is equal to 0. So I know Y is 2, Z is 0. So the last step, go back up to your original equations. Equation B. And I don't know what X is, but I know it's minus 3 times 2 because I plugged in this Y. Minus 2 times Z is 0. We just plug that in. Is equal to negative 7. Sorry, ran out of space there. So X minus 6 is equal to negative 7. If you add 6 to both sides, you get X is equal to negative 1. I don't care if you list them as X, Y, and Z, but remember, as multiple choice, it's going to be an ordered triple, which means X comes first, then your Y, then your Z. Now, that is a lot of work, but again, I will tell you, please remember, you could just do your multiple choice and plug those in and make sure the one that works for all 3 of them is your answer. And I'd be willing to bet that most of them, maybe all the other 3 answers, all 3 wrong answers, won't work with the first equation. So it's not like there's 4 options, 3 equations, so you have to plug in and do 12 different calculations. No, most of them you plugged into that first one, it's not going to work. And even if it does work for the first one, it's probably not going to work for the second one. Rarely does it happen where you get one that works with 2 equations, but not that third one. So again, keep that in mind. Multiple choice, you can also work backwards, plug your answers in, and double check. Okay, if you have any other questions, let me know. Remember, there is going to be another part. There was another part before this over some of the other chapters.